Hi everyone, welcome back to the Datomix Academy. Today we are tackling something that confuses a lot of beginners, even people with experience as well. SQL joins are one of the most powerful tools in databases, but let's be honest, they confuse almost everyone at first. Inner, left, right, full outer, they all sound similar, but produce completely different results. What if I told you that once you understand how SQL actually matches rows, joins will become incredibly simple? In this video, I'm not just going to show you the syntax. I'm going to explain exactly what's happening behind the scenes using real-world examples, visual tables, and row-by-row logic. By the end, you will understand SQL joins like a real data engineer. Joins in SQL let you combine rows from two tables based on a shared key, like a student ID, product ID, employee ID. Let's say we are working with a course platform. You have two tables. One of them is students, which has like the ID and name columns, and another one is enrollments, which has student ID and course columns. Now the question is, how do we connect these rows so that we can say which student is in which course? That's where joins come in. And before we deep dive into the joins, let's first pause here and explain the core logic, because this is the part of most people never truly understand. SQL joins work by comparing rows from one table to rows in another, using your own condition. For example, in our case, our own condition is like this. On ID from students table equals to student ID from enrollments table. Let's see what's happening here. SQL picks a row from students. For example, let's say it will be Alice, and it has ID with 1. And the SQL engine will scan enrollments table row by row. Each time it will try to find student ID, which is equal to 1. And it joins the rows together. So Alice gets this result set. It has like the course math and physics, and with IDs 1. Then SQL moves to Bob, for example, which has like ID equals to 2. And the SQL does the same logic here. It will try to look through enrollments table and finds history. Then again it will go through with Charlie, which has an ID equals to 3. And it cannot find any match for him. And if it's an inner join, like it will skip, and if it's a left join, it will keep Charlie, but fill the values with null. And we will talk about this later. And the engine is literally saying in this scenario, like, here is the one row, can I find a match in the other table? Engine will try to answer to this question. Well, now let's try to understand what inner join does. Inner join means only keep rows where both tables have a match. If there is no match on either side, the row is excluded. Let's try to work with our dataset. Let's try to match row by row. In our case, row 1 from enrollments table, student ID, is equal to 1, and the course is math. Can we find any student with ID equals to 1 in students table? The answer is yes. Row 2 from enrollments table, student ID equals to 1, and the course is physics. Do we have any record with ID equals to 1 in our students table? Yes, still Alice, and the output for the name column is Alice, for the course will be the physics. Row 3 from the enrollments table, student ID equals to 2, and course is history. Do we have any record which in our students table with ID equals to 2? Yes, that's Bob, and the output will be for the name column Bob, and for course column will be the history. And row 4 from enrollments table, student ID equals to 4, and the course is biology. Do we have any student in our students table with ID equals to 4? No, we do not have any kind of student with ID 4. That's why it will not be included, as we are doing inner join, and remember, in inner join we will get only the matching records. And for student Charlie, which has like ID 3, we do not have any enrollment as well. We do not have any student ID with 3 in our enrollment table. That's why it will not be included as well. And our final result will be like 2 rows for Alice, for math and physics, and 1 row for Bob, for history. What's happening here? SQL only showing rows where a match exists in both tables. Unmatched rows from either side will be excluded. As we said, inner join means like show only the records that match in both tables. So now that you understand how joins actually match rows, let's take a moment to look at how we write joins properly in SQL. Let's say we want to show which student is taking which course, as we talked. Here will be our SQL statement. Let's break this query down carefully, line by line, because every part of this matters. We have from part, and we have students. We are starting from the students table. But right after that, you see this letter, S, and that's called an alias. It's a shortcut name for the table. You can make it like either students as S or students S. It doesn't matter, they are the same meaning. From now on, instead of writing students.name, we can just write s.name. It saves space, keeps your query clean, and makes it easier to read, especially when you are joining multiple tables. Next line. We are bringing in the second table, enrollments, and giving it a shortcut alias with E. So now, instead of writing enrollments.studentID, we can just say e.studentID. Again, cleaner, shorter, easier to follow. And we have our own statement. This is the most important part. And it tells SQL only join these 2 rows when the student IDs in the left table match the student ID in the right table. This is the actual logic that controls which rows are joined. Without this on clause, SQL doesn't know how to match the data and things fall apart. If you forgot the on clause, SQL will go wild and combine every row from students with every row from enrollments. That's called a Cartesian product. If you have 3 students and 4 enrollments, you get 12 rows, even if none of them match. So remember, join says which tables and on says how to match them. You will also notice we write things like s.id or e.course. What is with the dot? That's called dot notation, and it's how SQL knows exactly where each column is coming from. You see, both of our tables might have a column called ID, or maybe they both have name. So if we just wrote select ID, SQL would say, from which table? I don't know, what do you mean? That's why we prefix column names with the table alias, like s.id, and it means student ID. e.course, for example, course name from enrollments table. So the dot means get this column from this specific table. Let's try to summarize our session. We have join part, and it tells what tables to combine, and we have on condition. It tells how to match them, and we also covered aliases. That's our shortcuts for cleaner queries, and we also understand dot, which tells SQL exactly which column from which table. This is the core of every SQL join you will ever write. Understand this structure and joins will never confuse you again.